Hi guys, my name is Gal. I work for MetaMask. I do JavaScript security there, and I currently focus on what we call the same origin concern. So I'd like to talk a little bit about what is the same origin concern, something that we've been working on. Um, give a little background for the problem, and then talk a little bit um, about some of the solutions that we've been working on for the past year and a half, and most importantly, some of the conclusions that came out of working about on this issue. So first of all, a little bit of background. So the fact that we embrace composability-driven development is great. We have web applications that are running on top of code of other people, and that is a great thing. But naturally, that also introduces security concerns. And when I think about it, these security concerns can be split into two main aspects. So the first aspect would be the build time concern. So the build time you might know is as supply chain and packages and dependencies, the fact that an application is being built and bundled to be executed later in the browser. So a lot of maliciousness can be introduced at that point. And we are definitely concerned about that. But there's a whole different aspect, which is the runtime aspect. So we also know it as ad services and third-party scripts in general. These are other ways to compose software, which is not through the build time. And this basically happens on the fly in the browser, and it's also a way to compose web applications. And that's also another way to introduce problematic security concerns and malicious code. So the motivation to that naturally is to try to come up with security tools to protect the runtime. So we're going to focus on runtime. We're not going to focus on the build time aspect because obviously the build time is definitely a problem, and there are a lot of attempts to secure that aspect, but it's regardless to the runtime aspect, and therefore we're going to focus on that today. So naturally, we see a rise in the need for runtime security tools. And I want to be more clear about what these runtime security tools are. So basically, we want to create JavaScript code that is destined to execute at runtime in the browser, in the web application. It could be installed via a third-party script. It could be installed as part of the bundling process, but the main point is that this JavaScript code is destined to run at runtime and attempt to protect the application. So by protect, that could mean a lot of things. We could try to observe and perhaps block behavior and access to sensitive operations at runtime, whether it's network, DOM, storage access. These are things that we might want to protect. We might want to limit in general the global environment in which the application is going to be executing in, to make it maybe less useful for attackers. And in general, just like alter functionality and the environment so that APIs are hardened and more secured. And I think this is a really important security layer because there are just so many parts of applications, traditional applications, that are being composed at runtime. So we have to find a way to protect these at runtime. So in reality, what this means is trying to apply some protection at runtime to the application. So this would be an oversimplified example, but it should give you the gist of it. So local storage is an example for a sensitive API where we might store sensitive information. So one thing that these security tools are trying to achieve is to have some security layer on top of the get item function, for example, and make sure that the application still has access to items if it has access to a predefined key, for example. But then if any malicious code has the ability to execute within the application, if it doesn't have the secret, they're not going to be able to access storage. So this is just an example of like things that security runtime tools can attempt to accomplish to perform better security. But there's a problem with that, and that is this that relates to the same origin concern. So ZB talked about same origin policies before, and this is a good place to talk about them also, because the browser is really good at protecting realms from each other if they are across the region to each other, which is great, because we compose software that way. We fetch information and functionality from cross regions, and we want to make sure that they don't have the ability to affect the main realm of the application. But the problem is that this naturally means the opposite. It means that if two realms are from the same region, they are completely trustworthy. And the way composability works today isn't really compatible with that, because nowadays, the way we compose software using supply chain and fetching scripts that run in the same realm as the application, they all run in the same realm. And we're talking about code that we don't necessarily know and trust. And they all execute in one same realm, and therefore it doesn't have any protection against same origin realms. This problem undermines such runtime security tools almost completely. And I would like to demonstrate exactly how, just for it to make sense. So if to take the former example, you can see here two techniques to access the local storage on top of the mechanism introduced before. So the first one is the get local storage naively, where we try to simply get item, and because of the security mechanism from before, and because of the fact that we don't provide the necessary secret, we're getting a null value. But the problem is that the bypass function can bypass that security mechanism very simply by just creating a new same origin realm and then reaching into that same origin realm's instance of local storage, which is not being protected by the security mechanism by default. In this context, the way we create a same origin realm is by using an iframe. So this bypasses the mechanism almost completely. And this example easily extends on. I mean, it doesn't have to stop at local storage. It could extend on to any security mechanism we're trying to apply. We're talking about DOM. We're talking about network access. We're talking about shaping the global object of the environment so that it's more secure. But if you can leverage yourself into another same origin realm, which is not protected by default, the security tools are going to have a really hard time protecting you. Which is why I think the same origin concern matters, which is why I want to talk about it today. So I've been working on this problem for a few years now, and I have implemented a JavaScript shim that is part of the work that we're doing at MetaMask. We call it Snow.js, and what it does is that it takes such security mechanism as demonstrated before, and it applies it automatically to all same origin realms that are being initiated in the application. So if an attacker creates the same origin realm and try to bypass your security mechanism, Snow would make sure to first take that security mechanism and apply it to the new same origin realm. But this solution is far from being adequate for two main reasons. First of all, security-wise, this is really difficult. Creating this as a JavaScript shim is really complicated. There are so many ways to create same origin realms, and we don't have the information from the browser to tell when these same origin realms are being created. So virtualizing it is really complicated, and the community managed to show us a lot of security gaps throughout the years in this scenario. And I think most importantly, even if this solution was perfectly secure, it would mean introducing a performance overhead, because the virtualization of the APIs that are protecting this problem just introduce a performance headache, sorry. So based on the conclusions from the solution we've been working on, we have a few ideas. I think the main point is that we're not sure how the solution should look, but the idea is that we want to be able to provide security against same origin realms for the application. So just to wrap up, this is the proposal part. We have a general idea of what we imagine. I think we can leverage existing APIs in the browser to achieve a solution. And I think CSP is a really good candidate for that, for two main reasons. The first reason is that CSP is already really good at enforcing rules onto realms recursively. It already does that perfectly, and that is exactly what we're trying to achieve with Snow, and what we want to be able to address this problem. And in general, CSP is just like an adequate mechanism for enforcing security policies in general, and this is a proposal for a security policy. So we imagine a new CSP directive. Its value could be to a remote JavaScript file path. And the idea, this is basically the idea. So what we had in mind is that if we take the example from before, you can see here that we implement the security mechanism in a remote path at the same origin as the application. And then we have a small CSP implementation here to ask the browser to take that JavaScript file and load it with every new same origin realm that comes to life before its document. And that way, it has the ability to shape all same origin realms, and that way protect them against each other. And it just does that using CSP. So that is basically the idea. I think the bottom line is that I want the problem to be clear, and I want it to be clear that the solution is just an idea. We're not sure what it should be. This is just like a way for me to demonstrate what we had in mind. And we would love to discuss it.